Hi, I'm Edwin. I am somewhere in between a designer and a developer. In practice, that means I make visual and interactive works, very often through programming it. Somewhere in 2010, I joined a studio called Last Lab, where I started making small interactive things. So this is one of the very first experiments that I made, and as you can see, it is with a Kinect sensor and a screen that shows the movie The Powers of 10. And the trick here is when I walk closer to the screen, I go deeper into the universe of The Powers of 10. So it's a very simple work, but I think it was a really fun way to interact with something that wasn't interactive before. Well, this experiment has led to a lot of works that are interactive, and actually most of them also work with this Kinect sensor. So, for example, this here is a work called the poster wall, and the idea for the poster wall was to pose ourselves the question, what would the design of a poster look like if we take away the graphic designer from the design process, and we replace that designer with a piece of software. So we have a piece of software that can read news through RSS feeds and tweets, and it generates posters from whatever it reads. Actually it's a very simple process. It's also a bit of an older project, so none of the fancy machine learning things that we see nowadays. But for example, this software could just pick up a single piece of news. For example, this piece about an earthquake. So the software takes this text and this image, and it does some simple processing on the image. You could use this image as the background for a poster, for example. It randomly picks a way to typographically treat the text and place it on top of the background, and we have a poster. So this software has like a number of ways to process the background. It has many ways to treat the typography, and combining those two sets of things, we can generate a very large set of posters. And some of them are really ugly looking, and some of them are actually surprisingly good. For some reason, the right choices of background and typographic treatment was made, and it actually looks nice. Since these posters are never really printed, they stay in the digital domain, we had to find something else for gluing the posters to the wall. So we made this interactive setup where posters are projected on a wall, and the wall is interactive. You can walk past the wall. You can reveal posters that are behind posters that are virtually glued to it. There are ways to interact with the posters. You can scan a QR code, and you will get a copy on your phone. I would just take a picture of the poster. And there is also some other functionality where you can create your own poster by tweeting to the poster wall. I think if we wait a bit, we get to. Yeah, this was really cool back then. Wait for it. Yeah, there it is. So it's this idea of posters, it's kind of stuck with us, and for a a film festival in the Netherlands, we were invited to make another installation that could create posters for the films that were playing at this festival. And we found it an interesting idea to use the body of the visitor as an interface to the movies that are playing. So we had this very romantic idea of matching like the body pose of the person in front of that installation against scenes from the movies that are playing. So some early testing would look like this. Here I am switching between John Travolta and Once Upon a Time in the West, I think. So yeah, this worked really nicely, but to make the actual installation out of it, we had to do a bit more than switching between two scenes. So here's a small overview of all the parts involved in this installation. So here we see someone standing in front of it. We see that we can see the pose, and then here are all the scenes that match that pose. So you see that swimming scene was much larger when that scene matched with the person standing in front, posing like he's swimming. So here we have sort of the skeleton of the poster. We see that like there's a large space for the high pose similarity, and we also add some other data like the actors who are playing in this movie, and there's this schedule at what times the movies were playing at the festival, and we also scraped the internet for reviews of these movies. And there was even, attached to this festival, there was an award. So as soon as we knew that a movie was nominated for such an award, we would also add the text of the nomination or the award. Now there was a fun story about the extraction of the poses from the movies that we were showing in this installation. And when we began this project, we were more or less promised that there would be technology to automatically extract these poses from movies. That didn't happen. So instead, we had to reenact a lot of these scenes. So we had to take the movies, find the parts where there were interesting poses, and then cut out that small piece, and then reenact that piece. And what you see here is pretty much like a visualization of the database of poses that are in the movies. So some results of the posters. I think these are actually compared to the actual posters for these movies. They're all Dutch movies, and there is sort of almost like a tradition to make really bad posters for Dutch movies. So I think this is pretty nice. So more of them. Yeah, a question that always pops up, at least for me, and I think also for the people I work with, is what does the world look like when looking at the world through machines or through systems or sensors? And one of the funniest ways to look at the world, I think, is to look at Street View. We all know Street View, and we also, some of you may know that this interface, it's actually like a sphere, and inside the sphere, there is like a texture wrapped on it. So it looks like it is 3D, but it isn't really. So you can actually unwrap this sphere and you get an image like this. The thing that we were wondering is like, if you would be able to, for a single city, scrape all those images, and you would visualize those images again, what would you then get? So we actually wrote that scraper, and we got a lot of these Street View images, which is probably not a legal thing to do. And we made these really interesting looking maps just by drawing those same spheres again, but with the texture on the outside. So you see this really interesting streets. This is the city of Milano, by the way. So this work, with this data, we wanted to do something, so we made an installation around it that takes this data again and brings it in an even stranger place. And this is done by projecting those images essentially on styrofoam balls, like the type of balls you use for flower arrangement. So we once again we created an interactive space. So there's Kinects, and these balls, we made them look a bit like eyes, and if you would walk past them, those eyes would follow you. And what is actually the really interesting thing is that it is also the streets that always look at you. So when you walk past by, it's actually a street movement like this. Yeah, we put a lot of work in making those animations really, somewhere in between organic and mechanical looking. Yeah. So that process still continued, but we were wondering, since we have picked the locations ourselves for this installation, if it wasn't possible for a machine to pick an interesting location and to create a space for that location. We were working with things like in the news, finding places that are mentioned often because there were events going on there. And one of those places was, at that time, was Sochi because of the Winter Olympics. So the software picks that place. There's this image that we found of Sochi in Street View. Not exactly the Olympic setting you'd expect. And we would also scrape a lot of the news. So we get a lot of data about this place, small little stories. But we still needed a place to place those stories. So we came up with a little trick. So you take an image, and you just remove the pixels, is what I would call it. So you get this. This is a grid that matches somehow the structure of the original image, but there's a lot of empty spaces in there, which I think is a great place to place those stories again. So this is what that space became. So it's this grid with all those stories placed in there. And we see this room as a teleporter room. Like a visitor comes in there and he is taken to a different place, and this different place is visualized in the most abstract way possible. Quickly show how that looks. Oh yeah, again, interactive, with a lot of Kinects and a lot of projection. The idea is that you can walk towards those walls, and then you would zoom in on such a story, and you can zoom in so far that you would see one single story, built up in a recursive fashion out of surrounding stories. So now we come to the point where I tell about what is behind the making of these things. We built all of these installations with our own tooling. So over the time we have developed a toolkit that allows us to write this software that has these pretty high demands for visual graphics, for real-time rendering, for interaction, for very strange setups with hardware, interacting with all kinds of third-party systems, and that became OPENRNDR. And that started somewhere in 2013 with the great initial commit. You got to start somewhere. So at this point, OPENRNDR is an open source project. You can start using it yourself at any point in time if you want. And I would like to show how you could start using this. So most of our projects start with a Gradle file that you define which OPENRNDR artifacts you are using. So your very first program ever is going to look like this. There's a first program ever class that inherits from the program class, and there's a draw function. Inside this draw function, you tell the drawer to use pink for the fill, and there will be no stroke. Then we draw a circle at the center of the screen. And of course, there must be an entry point somewhere, so there's our main, and there's just all the logic to actually start the program. So the result is a circle. But we can make this a bit nicer. We can say, well, instead of drawing that circle at the center of the screen, let's use the mouse position. So there we have it. Interactive visuals. OPENRNDR has some pretty nice functionalities for animating objects. And there's a small language in which you can make your own object that inherits from the animatable class, and that enables a little language where you can express things like, okay, this object move to X, which is on the right side of the screen, wait there for a bit, then move back, and wait there again. And this animation is made every time that this object doesn't have an animation. So what we see is a nice point moving. Those things can easily be extended to be a bit more complex by just drawing more of the same thing. Another important thing for visuals and in OPENRNDR is to transform objects. Like, so we have seen objects move, but we also want to maybe rotate them or scale them. There's a small language in which you can express rotations and translations. People who have ever worked with a graphics API might recognize the order of these things. So we can make a rotating rectangle. We can extend on this again by drawing a lot more of them. We can change the way that we rotate them by specifying for each object, depending on where it's on the screen, a slightly different rotation. So those are squares and circles, but it would be nice if we could also specify a bit more complex shapes. And it would be nice if we can do this in programming. You can also load shapes from Svg files, but I think doing this in code offers some interesting possibilities. So here we make, tada, it's a rectangle again, but we can make this a bit more interesting by adding those distortion factors that you see there and moving a number of those points around. So you get this object, and it is distorting. Well, we have seen that every shape is made out of at least one contour that describes the outside of the object, and that we offer some nice tools to do some manipulations of that contour. We can, for example, we can take that contour and we can cut out a little part, and we can cut out that little part and we can animate it. So, for example, here we see like this little worm-like thing moving over the contours of this shape. And that too we can make more complex. Another option is, instead of using these worm-like shapes, to generate points that are on this contour. So here we see some small code that uses equidistant positions to generate 40 points on the contour. And when animated, we see 40 points nicely moving over the contour. This too we can make a bit more complex by just drawing more of the same thing. Another interesting thing in OpenRNDR, since everything is hardware accelerated, at some point you deal with a shader. And I'm not going into so much detail about what a shader is, but the interesting thing is that you can slightly change the behavior of the default shaders in OpenRNDR. So for example here, I made something that's called a shade style, and there's a fragment transform that takes the position on the object and uses it to calculate a gradient. Yeah, it's basically a gradient. So that would look like this. We can also feed data into these transforms or these shade styles using parameters. So here, instead of having a static thing, I feed the mouse position into the shade style again. So here we see that thing moving. This is a little thing that uses mostly the history of mouse positions to draw a grid of rectangles with this shade style on there. So you get this. Then there's a lot of work done on rendering type. So here we have like a very simple typer effect. We can make that, again, more complex by drawing more of the same thing and slightly changing the offsets of the effect used. Then we can combine the typography with the shade styles again to make like this stepping effect. And we can make that more complex. And we can load images. My time is almost up. We can apply filters to those images. And we can, in the end, there's something called render targets, and that allows you to, instead of loading an image, you can draw in an image, and you can apply those same filters again. So for example, this circle is drawn first to an image, and this image is then blurred, and all the parameters are animated in the code. All right. I think I have to wrap up here. So to recap, I've shown some interesting things that make visual and interactive programming. I think it makes it easy. The examples are a bit limited in scope, of course, but Yeah, I can only invite you to try it out yourself. We have a website called OPENRNDR.org. Thank you.
Okay. Yeah. So we got a few questions. How can you find your where can you find your wall work? So
the eye wall work,
yeah.
the poster wall work, or
all
of the
know,
works?
All of the works.
All of the works. Well, that's the sad thing with these type of works is like you install them and they have a temporary life for some weeks or
maybe
months if you're
source
lucky.
Source code on GitHub or something.
Oh, source code for the older projects?
No.
Okay. I would love for that to exist, but
was OpenClip also created with OpenRNDR? So OpenClip video.
Yeah, that was also in OpenRNDR, and actually that runs in real time if you have a moderately fast computer.
Okay, and why Kotlin?
Why Kotlin? I think it's a very interesting and fresh language, and it allows you to simplify this kind of program a lot. So there are features like like everybody is selling on the DSL things, and I have to do the same. It's really easy to express visual things in those DSLs.
Cool. What technology do you use to work with GPUs?
What we use, it's currently everything is OpenGL 3.3, and that is because we had to pick a baseline that works on all three platforms, so Windows, Linux, and Mac OS. And maybe in the future we want to do a Falcon backend, but maybe.
Okay, I think we run out of time, so you can ask this question directly to Edwin later. So that's all.